Hello. In this presentation, we will be discussing the final project for robotics. I will be starting with the general idea, reasoning, and the concept. And then Simon will be going over the code implementation and showing a demo. So our project is about building a system of robots for demining. Now you may be asking, what is demining? So, leftover landmines are a very major issue in many countries like Iraq and Afghanistan. They pose a major threat to humans, wildlife, and even limit infrastructure growth. Demining is a process of clearing these minefields by removing or detonating the landmines. Over the last couple of decades, large amount of money and resources have been dedicated for this effort. Even in 2016 alone, almost $350 million were used for landmine clearance and risk education. So here are some examples for mine clearance procedures used till recently. And these. So as you can see in all these examples, there is either danger to humans and animals, or the solutions are very expensive. Our solution is much cheaper than the previous examples, like using a real tank, while also being totally safe. We have designed a system of multiple robots or drones which clears the specified area by detonating the mines, while the operator is at a safe distance far away. So the actual minefield is implemented as a grid, and all the obstacles are pre-marked on the grid. So a robot traverses the grid using a variation of Grassfire algorithm, visiting cell by cell while avoiding the obstacles. While traversing the grid, if a robot detects a mine, it drills into the ground and detonates the mine, and also the robot is destroyed in this detonation. Once destroyed, the next robot goes to the last robot's final location and continues the traversal till it hits next mine, or till every cell has been checked. So the physical robots themselves, each robot is built cheap, as its goal is to be eventually destroyed. Other than movement system, the two components of the robot are metal detector and a drill. When a robot detects metal underground, the operator looks at the data, like scans to identify if it's a mine or any harmless object, like a metal coin or something. If it's a harmless object, the robot can skip. If it's a mine, the operator issues the command to start drilling. Here I'll show you the short animation on the actual traversal. So the blue diamonds are obstacles, and red stars are the landmines. So the robot starts traversing it. When an obstacle comes, it avoids the obstacles and keeps going. And during this process, you will notice that these two cells here were not visited, which is okay, as once it completes its first run, it will look for all the unvisited cells and then check those later on. So when a robot encounters a mine, it detonates it, and this is where the next robot takes over. So this is robot number 2 completing the same traversal. Once the traversal has been completed, then the robot goes over to the unvisited cells. So in this case, it starts here, and then it clears another mine, and then next robot takes over and visits the next unvisited cell. So after this movement, every cell has been checked, and the entire field has been cleared. So That is all from my end, and I will pass it on to Simon to.
Hey, this is Simon, and we're going to be going over the algorithm today in the code. Each frame in Unity, we're checking whether or not the current drone is dead. If it is dead, we will be sending out a new drone with the method within the same script, which is called sendoutDrone. In there, we basically make sure we check the last location of the previous drone and see whether or not we can find a non-checked cell right beside it, which we can set as the new location for the new drone. Or if it seems like the last drone was blocked in, either by check cells or by object cells, we then just move on and find a brand new location somewhere where it's not checked or there's a mine. However, the reason why mine is also looked for is because to the parent, when it's actually being run, we do not know where the mine is. The mine there is only there just for debugging purposes, just to show that the drone is actually going towards a mine. Otherwise, in actual like realistic scenarios, the mine is not known, and we're simply looking for non-checked areas. A mine location would be a non-checked area, either way. So within the actual drone script, we have this method called go side to side, which just returns a multi-dimensional text mesh array. Basically, this method is used as sort of the main method for the actual modified Grassfire algorithm, and it abstracts most of the processes behind other methods, which I'll explain. So this text mesh, it basically, well, this text mesh method, multi-dimension, which returns a multi-dimensional text mesh, takes in parameters from the parent object map to follow, which is also a multi-dimensional text mesh array. It takes another two parameters, which is basically out integer array drone last location and out boolean array can move O. Basically, those are going to be two parameters which we're also going to be kind of returning back to the parent object, so it can properly choose the next location. Next, we have our multi-dimensional array resistance map. We actually call on the resistance map get resistance map method, which basically builds us a multi-dimensional resistance map, which the drone can use to pick the proper cell to actually go to. And we have string next position, which is basically used in one of those methods to actually return which position it should go to next. Next, we have a loop where we go until the basically the array area of the actual grid. This is just to avoid any idling situations. This can be modified maybe for user preference if it were to actually be deployed. Next, within the loop, we check the cell current state. So we just check what the current cell is that we're standing on. Basically, if it's a mine, we break. If not, we we just set it to actually a checked cell. So next we check set can move. We actually just basically that's modifying a Boolean array, which goes sort of it has four indexes, and they basically all are sort of an analogy to right, up, bottom, and left. So basically, index 0 is right, and therefore so on and so forth. So we basically just check which cell we can actually go to and return that. Next, we do counterclockwise choose, and we just pass in the current position of the drone. So this is important because we are trying to recommend the drone goes in a counterclockwise direction. Basically, it just checks that by having like the distance to each side, and then through if statements, it can pick a recommended path for the recommended direction that the drone should go into. And again, this is actually just returning a Boolean array, which it just only has one true statement, and that true statement is the recommended cell. Next, we actually go to get resistance on cell. We pass in the resistance map. Here, we basically just check all the available cells that we can check, and we go through the resistance rule check to add in, add the resistance to each one of those cells. This is going to be used later on to actually pick our cell by just looking at the minimum like resistance cell, minimum resistance. So we have four, let's say you're standing in the middle, we have four cells around you. You would look through all four of those cells and pick the one with the minimum resistance, and you would go forward from there. So that's kind of taking on from Grassfire, but instead of just adding one, we kind of elaborate on the actual weights a little bit more. Next, we actually just choose the next position. So we just set the string next position, next pose to choose next pose resistance map. So we basically, that's where we pick the minimum and we just say this is the direction we're going in. And then we actually move the drone in that direction by just passing in our current position and our next position. And then that way we'll actually get the position that we want to move in. And then if we actually come to a state where our loop cancels or we reach a mine, we are basically checking which ones we can move to again before we actually start returning all of the stuff, like those out parameters and the actual text mesh, just so the parent object can properly choose which cell to go to.